People often call it the moon's dark side, but this is not quite true. The far side isn't always dark, it gets plenty of sunlight, it has days and nights just like the side we see. The sun shines on it. It is a sunlit landscape, just like our own. Why the name dark side then? It's because we can't see it. Not from Earth anyway, it stays hidden from our view. This made it seem mysterious. For centuries people wondered about it. It was a place of secrets, a canvas for imagination. Both sides of the moon have day and night. The moon spins on its axis. Different parts face the sun at different times. A lunar day is very long. It lasts about 29.5 Earth days. So the far side gets 2 weeks of sun. Then it experiences 2 weeks of darkness. This cycle of light and shadow is constant. We only ever see one side of the moon. This is due to something called tidal locking. It's a special cosmic dance between the Earth and the moon. This happened a very long time ago. Earth's gravity changed the moon's spin. Let's explore this fascinating phenomenon. It is key to understanding our lunar companion. What is tidal locking? It sounds complex perhaps, but it is quite simple to understand. The moon spins on its own axis, much like Earth spinning to give us our day. The moon also orbits or travels around Earth. These two movements are now perfectly matched. This synchronization is the heart of tidal locking. The moon takes the same amount of time to spin once on its axis as it does to orbit Earth once. This period is about 27.3 Earth days. Imagine spinning around while also walking in a circle. If you time it just right, you always face inwards. The moon does exactly this with Earth. It's a beautifully coordinated celestial motion. Think of a dancer holding hands with a partner. They spin around each other in a graceful turn. The dancer always keeps their face towards their partner. The moon performs a similar dance with Earth. Earth's strong gravity caused this effect. Over billions of years, it slowed the moon's rotation until it locked in this constant embrace. One side forever gazing at our planet. This tidal locking is not just for our moon. Many moons throughout our solar system are locked. They are tidally locked to their parent planets. It's a common outcome of gravitational forces. Gravity stretches and pulls these celestial bodies. Over vast timescales, this leads to synchronization. It is a natural process in the universe. Our moon is a wonderful nearby example. The moon's far side looks very different. It is not like the near side that we know so well. One big difference is the sheer number of craters. The far side is absolutely covered in them. These are like ancient scars from countless impacts. Space rocks like asteroids and comets made them. It is a much more rugged and battered landscape, testament to a violent history. Why are there so many more craters there? Earth actually helps to protect the near side. Our planet acts like a gravitational shield. It pulls in some of the incoming space debris, or it deflects some of it away from the moon, so the near side gets fewer direct hits. The far side, however, faces outer space more directly. It bears the full brunt of these cosmic collisions. The moon's crust is also significantly different. On the far side, the crust is much thicker. It is also generally older than the near side's crust. This increased thickness made it very hard for magma. Magma is hot, molten rock from deep inside the moon. Because it was harder for magma to reach the surface, fewer large, dark volcanic plains or maria formed there. These maria are the seas we see on the near side. The near side, in contrast, has a thinner crust. This allowed magma to erupt and flow out more easily. This happened in the distant past, billions of years ago. These vast lava flows cooled and solidified. They created the dark, relatively smooth areas we observe. We call them lunar seas, like the Sea of Tranquility. The far side does have some maria, but they are smaller, and they are much less common than on the familiar face. For a very long time we only saw pictures. These images came from space probes flying past. They gave us our first glimpses of this hidden realm. But in January 2019, something truly amazing changed that. China's Chang'e. 4 missions successfully landed there. It was the very first spacecraft to make a soft landing on the surface of the moon's far side. This was a monumental step in lunar exploration. The Chang'e, 4-lander and its rover, named Yutu-2, are vital. They are diligently studying the far side's geology. They look closely at its ancient rocks and unique soil. This helps us understand how the moon itself formed, and how it has evolved over billions of years. We learn so much from their ongoing mission. Each piece of data is a new piece of the puzzle, unlocking secrets held for eons. The far side is also incredibly special for another reason. It is exceptionally quiet in terms of radio waves. Earth is a very noisy planet, electromagnetically speaking, with signals from TV, radio, and all our mobile phones. This constant human-made noise blocks faint signals from deep space. The far side is shielded from this interference by the moon itself. It's a perfect, pristine listening post for radio astronomy. We could listen to the whispers of the early universe. The moon's far side is no longer totally unknown to us, but it still holds many captivating mysteries. We are just beginning to truly explore this alien landscape. Imagine standing there one day, on its ancient dust, looking up at a star-filled sky without Earth in view. What further wonders might we discover next? What secrets are waiting to be unveiled on this hidden face of our moon?